This is number 24 on our study guide. We're giving another proof here, so this is going to be statements, and it's going to be reasons. If you'll notice, we've been given information about it being a rhombus, and we have two sides that are congruent, and we're supposed to prove that we've got that the two smaller triangles are going to be congruent. So I'm going to start with number 1, in which I say ABCD is a rhombus. And then I'm going to call that given. And I'm going to go ahead and just throw the other statement here as well. Usually I break it up, but I'm just going to go ahead and put that in there. DF is congruent to BE. And again, that was given to me. So DF is congruent to BE. If we know that this is a rhombus, what do we know about a rhombus? Well, we know the opposite sides of a rhombus are congruent. I don't really need this side. This doesn't really help me out. But to know that these two sides here are going to be congruent, that's going to be helpful. So I'm going to go ahead and say that AB is congruent to CD, and the reason is going to be that all sides of a rhombus are congruent. That's one of our theorems. So I now have that this is congruent to this. So I've got two things. There's not really a way for me to do the third side here, so I can't use side, side, side. But I can get the angle that's included in between them. So I can say that angle D is going to be congruent to angle B. And the reason that's going to be, right here in this, is that if it's a rhombus, then we have the property that says the opposite angles of a rhombus are congruent. Now if you'll look, we've got a side, an angle, and a side. So number 4, I can state that triangle ABE is congruent to triangle CDF, and the reason is going to be because of SAS theorem.